Okay, here's our second video from section 11.3 talking about combinations. And we're going to compare again real quick combinations and permutations. Remember, permutations is when order does matter. Rearranging things makes a difference. But combinations, order does not matter. So look at the letters A, B, C, and D. And if I told you that you had those four letters and I wanted you to pick three of them, if I said that order matters, wouldn't you be able to take three of those letters, A, B, C, A, B, D, A, C, D, or B, C, D, and rearrange them a whole bunch of different ways if order mattered, and we could rearrange them and get a new arrangement every single time? That's 1, 2, 3, 4, 5, 6. 6 different ways with the 3 times 4. 6 times 4, that's 24 different ways you could arrange three letters if you're given 4 of them, right? If order matters. Now, if order didn't matter, and I wanted you to take those 4 letters and choose 3 of them, then this would be one group of A, B, and C. Well, if order doesn't matter, then I can't count all of these as a different way because order doesn't matter. You've just picked A, B, and C. You've checked A, B, and C off of your list. I don't care what order it's in. That's just one combination of those same 3 letters. Order doesn't matter. That's just one way. That means A, B, and D is a second way. That means A, C, and D is a third way. And that means that B, C, and D is a fourth way. If order doesn't matter and you're doing combinations, you really only have 4 different ways of picking 3 letters from the letters A, B, C, and D. See, that's a huge difference, right? The difference between permutations, when order matters, you could rearrange and add more and more and more. But when order doesn't matter, you have less ways to pick a certain number of items out of a group, combinations. So, just like there is a formula for our permutations that we learned in the last section, there's also a formula for combinations, because our numbers, remember, are going to turn out a little bit different. And so the combinations formula looks like this, very similar to the permutations, so make sure you write it down. Remember that N is the total number of items you have, and R is the number of items that you're going to choose. Do you see the difference here on this formula? Uses a C instead of a P, so that I know you understand that it's a combination instead of a permutation. The first little part looks similar to the permutation equation. We have an N factorial over an N minus R factorial. But there's a little bit of a difference on this equation. We have this extra R factorial in our denominator. What that kind of does is it gets rid of all of the times that we repeat all the letters that we chose before, or all the items that we chose, because order doesn't matter. So make sure you know how to use this formula when we have a combinations problem. Let's do a few of these. In example number 2, it says a 3-person committee is needed to study ways of improving public transportation. How many committees can be formed from the 8 people on the Board of Supervisors? So we have a total of 8 people, and we want to pick 3. We have 8 people. We want to choose 3 of them to be on a committee. Now let's think, does order matter? Well, it doesn't necessarily matter how we pick these people. It doesn't matter how they sit at the table. We're just asking them to vote or give us their opinion on this public transportation, right? So to me, in this example, order would not matter. This would be an example of a combination. So I know this is a combination. I know that I have a total of 8 people, and I want to choose 3 of them. So I'm going to set up my combinations formula as 8 choose 3. I'm going to plug in my numbers. I have an 8 factorial over an 8 minus 3 factorial times another 3 factorial. Simplifying it a little bit, I have an 8 factorial over 5 factorial times 3 factorial. Remember now, don't multiply the 5 and the 3 yet. It doesn't work out the same mathematically. We're going to write them out individually. So on the numerator, I have an 8 times 7 times 6 times 5 factorial, because the 5 factorial on the top will reduce with the 5 factorial on the bottom. But don't forget, we still have a 3 factorial. That's a 3 times 2 times 1 still in that denominator. So on the top, I need you to multiply 8 times 7 times 6. I need you to multiply 3 times 2 times 1. And then I need you to divide those two numbers. If you have 8 people on your Board of Supervisors and you need to pick 3 people to be on your committee, you have 56 ways of picking 3 people to be on your committee if you have a choice of 8 total. All right, let's look at number 3. In poker, a person is dealt 5 cards from a standard 52 card deck. The order in which the 5 cards are received does not matter. right? They're going to give you 5 cards. It doesn't matter which order they put it on the table. You still have the same crappy 5 cards. At least I always do, right? So how many different 5-card poker hands are possible? Well, because it doesn't matter which way they hand you those 5 cards, it's still the same 5 cards no matter how you rearrange them on your table. Order does not matter, and this would be an example, another example of a combination. We have how many cards total? 52, right? And we're dealt 5 out of those 52. How many ways can that happen? Well, let's use our combinations formula and plug in our numbers. I've got 52 factorial over 52 minus 5 factorial times another 5 factorial. Simplifying it a little bit, I've got a 52 factorial over 47 factorial times another 5 factorial. Writing all the pieces out, I've got 52, 51, 50, 49, 48. I'm going to stop at 47 factorial because that 47 factorial and all of the numbers below it, and the 47 factorial and all the numbers below it will reduce. But don't forget, you still have a 5 factorial in the bottom. That's not just a 5. It's a 5 times 4 times 3 times 2 times 1. I need you now to multiply the top numbers. I need you to multiply the bottom numbers. Write both of those down and then divide them. In poker, how many different ways can the dealer give you those 5 cards? Woo! 2,598,960 different ways they can hand you those 5 cards. All right, the last example we're going to look at here is a little bit different, so stay with me. It says here, a zoo has 6 male bears and 7 female bears. 2 male bears and 3 female bears will be selected for an animal exchange program with another zoo. How many 5-bear collections are possible? So we have to first think, if we have male bears and female bears and we want to pick some of them to go to a zoo, does it matter how you put them in the cage or bring them to the zoo? Isn't it still the same bears no matter what order? And so this would be another example of a combination. Okay, now it's going to be kind of easy because when you're doing your homework for this section, they're pretty much all going to be combinations, right? Because that's what this section is. But what I'd like you to think about is what happens if they were all out of order and you didn't know what section this was from? Would you still be able to determine the difference between a combination and a permutation? So that's really important. And we'll talk about some extra worksheets I have available for you here in a second. But back to the example. So we have male bears and female bears. And so we have to set this up a little bit different because there's 2 different type of categories. We're not just picking from a deck of cards or picking from a committee, and it doesn't matter who we pick, male or female. We're just picking people. In this particular case, because we need to specifically pick males and specifically pick females, we've got to set it up into 2 different categories. So we have a male category and a female category. Okay? So how many male bears are there total? Well, it says here that there is 6 male bears. And how many of those male bears are we going to send to the other zoo? Well, we want to pick 2 of them, right? And because order doesn't matter, we're going to set up a combination with a 6 choose 2. We have 6 male bears and we want to pick 2 of them. I'm going to do that combinations formula off to the side, calculate the total, and I end up getting 15. I'll show you in a second a video of how you can do that really quickly without having to do it all step by step by step. So hang on with me and I'll show you a trick with your calculator, okay? All right, looking at the female bears, how many female bears do we have total? Well, it looks like we have 7 female bears total and we want to pick 3 of them. So we have a total of 5 bears, right? 2 male bears and 3 female bears. Remember again, order doesn't matter, so we're still doing a combination, this time with a 7 choose 3. Off to the side, you can practice doing it the long way. I'll show you a shortcut here in a second, and then from now on you can use the shortcut. But I'd still like you to practice the long way just one more time. All right, I ended up getting 35, did you? All right, but my answer isn't 15, and my answer isn't 35, because I want to be able to figure out how many male bears and female bears. Now remember the fundamental counting principle from our first section? If I want to pick pants and shirts, male bears and female bears, do you remember what I did with my options? What mathematically I did with my options? Yeah, didn't I multiply them together so I can get the total number of ways I can pick males and females, pants and shirts? So I'm going to take the 15 and multiply it by the 35. And so there are a total of 525 ways that I can pick 2 male bears and 3 female bears to send to the other zoo from the group of bears that I have. Okay, that one's a little bit different because there's 2 different type of categories, so make sure you practice those type in your homework, okay? All right, 2 things I wanted to remind you of. Make sure that you watch the calculator video. That's after this. I'm going to show you a trick of how to do the permutations formula and the combinations formula in your calculator so you don't have to write it all out. I showed you the long way because I wanted you to really understand what it was, but now that we know what it is, let's save some time and let's just use our calculators. So make sure you watch that video so I can show you how to use your calculator to kind of give you a little shortcut. The second one, I would really like you to look in Canvas underneath the modules and find the combinations, permutations, and counting principle practice worksheet. This is going to be a really good worksheet to help you kind of review the first 3 sections before we get a little bit harder. And what I've done on this worksheet is I've mixed and matched all of the different ideas we've talked about in these 3 sections, because it was kind of easy when all we were doing is focused on 11.1 counting principle. And it was kind of easy still when we did permutations and we were only focused on permutations. And it was easy when we were only focused on combinations just now because all of our examples were the same. But if they're mixed up, like they might be on the test, it's going to get a lot harder. So I'd really like you to practice that worksheet. They're all mixed up so you can kind of get an idea of how to tell if it's a combination or a permutation or a counting principle, and then how to use the formulas. So print out a blank one, do it, and then double check your answers with my answer key on Canvas, okay? It'll give you a really good idea of how well you're doing on the first 3 sections. And it's really important to understand the first 3 sections because we're going to add to it a lot in the next couple of sections, okay? So make sure you get a good foundation. All right, let me know if you guys need anything, have any questions. We have a good first start on chapter 11, but we're going to get a little bit harder. I think it's fun, but hopefully you will too.